We'll start with a simple web-based user interface that I've created to help us explore the data. Down the bottom, we have a text input, which is where we're going to pose our user questions, and at the top, we have a selector for which data type we want to explore. So we're going to start with the structured data, keeping in mind that these are entries relating to customers, products, orders, and logistical updates. In here, I'm going to ask about Ed, who is one of our customers. What's happening in the background is the large language model has extracted Ed as a subject, created a Cypher query looking for all the relationships or edges that are stored, and then executed against the database. Looking at the response generated, we can see that Ed was waiting for their order to be delivered, alongside a summary of products that were included and a list of logistical updates. Additionally, it's giving us more information than we asked for, which was the fact that Ed has made multiple inquiries about the status of the order and then requested a cancellation. Lastly, there's the response to the initial ask, indicating they're still waiting for an order resolution. Let's switch the subject type and look for an order instead. This time around, we've matched an order detail node. The response is providing the contents of that order and also giving us some information about logistical updates. Listed is the creation time, the fact that it's been picked, dispatched, and finally delivered to the customer. Let's pivot the subject to a different customer that doesn't have much information listed. Stored within the graph this time, we only have a single vertex for information relating to Pauline, which is her registration date within the e-commerce platform. So moving on to more interesting data. I'm going to change my selector to be the unstructured index. This time, I'm going to explore some of the products that have user-submitted reviews that were processed and ingested. If we scroll to the top, you'll see here that it's giving us a light summary and then a list of negative aspects that were found within the graph. For these aspects, we've relied on Claude 3 Sonnet to process and understand which details are important from the reviews. These range from mentions of performance, build quality, and many more that haven't been mentioned in this response. If we then try to zero in on an individual aspect about one of these products, we can probe for specifics, such as mentions of battery life. Again, the model is extracting the product that has been mentioned, and it's also looking for specific relationships that could relate to the target search. Now it's come back with a list of mentions from the reviews and an overall summary to answer the questions. Let's take this a little bit further. For this query, we're actually going to look at the differences between two different products. When our agent is running this time, there are two core nodes that will be returned. One will be the everything phone and the other will be the Zephyr. From here, the large language model will iterate through each of the different mentioned areas that have been extracted from the ingested reviews. In the response, we can see it started with the everything phone, and it's come back with a summarized list of all the graph edges that were found. Underneath, as expected, is the second product too. We can even compare specific relationships between nodes. Once again, we have the two core nodes being focused on, and specific edges have been found and then used for a final summary. Now we've seen how a search experience could play out, we're going to switch and have a look at how the data's been stored. Here you'll see my local graph database. Vertically stacked are two separate indexes. The top one is the structured data from our relational stores, and the bottom one is the unstructured data. If we maximize our structured data view, you'll see in here that I have a number of these more isolated groupings being represented. Towards the left, we'll see a couple of details here about Ed. This starts with his core customer node, which is connected to some inquiries that he's made, his registration date, and an order with products from the website with logistical updates. If we swing across to the center of the map and look at our second customer, we'll find Sam. Present is his registration date, as well as some details about 2 different orders, both with varying pieces of information that are available. If I move towards the top of the graph, you'll see there's a smaller ontology here. This one doesn't reflect much information apart from the fact that all 3 members were registered at the same time. Minimizing this view, let's have a look at the unstructured data. Now this is where the graph view is a bit more interesting and chaotic. You'll notice in here that we actually have a fairly big mesh of all the nodes and a large number of overlapping pieces of information that have been discovered. If I move across to the left here and highlight one of them, we'll find the everyday phone epicenter. For this product, all the edges and their connections are representative of the details that were extracted from the product reviews. Switching to view another product, if we drag our map across to the right, we'll see another more central node representing the Zephyr. One thing to note is the shared relationships between products. We can see that they both connect on the insight around being average, however in different ways. If we move up to the top, we have another product called the Everything Phone, which while entwined with other data, didn't appear in any of the other results from my earlier search queries. Changing the view to my IDE, I'm going to touch on how all of this was built and instrumented. We're going to start with the ingestion script. In here, you'll see we're including Boto3 to call AWS services, then a number of specific imports from an open source framework called Llama Index. Now, this is the heart of the process as it facilitates the extraction, ingestion, and also the exploration of the data. If we scroll down, I'm specifying an embedding model we want to transform the data with. This is because when we search our graph data, we want to perform semantic comparisons rather than just text matching. We have the text generation model, which is used to extrapolate the subjects from their properties and relationships, and it's also what we've used for converting our queries to Cypher. Next is the connection information to instruct our script how to reach our GraphDB. On this, it's local for the demonstration. But if you're running this within AWS, we could just as easily use a service like Amazon Neptune. Further on, there are a couple of properties here which determine how the ingestion should behave. For starters, we're directing the process to use embeddings for when we populate the nodes and edges. Then we're also specifying how many tuples or triplets we want to extract from the unstructured data. The higher this number, the more pieces of information we're aiming to understand within the reviews. The last define we have here is where we want to pull our data from. For this demonstration, I've previously generated approximately 100 user reviews using Amazon Bedrock. If I browse through a couple of these, we'll see that some of them are pretty straightforward single-liners. However, if we have a look through a few more, we'll eventually get to some which are multi-line. The main callout is that our unstructured data varies in terms of the complexity, verbosity, and details contained. To easily combat this, using frameworks such as Llama Index allows us to control behaviors as easily as changing the number we mentioned earlier. Continuing down, we have our Bedrock client instantiation, as well as the default embedding and text generation models to use for Llama Index. Using settings like this allows any and all subsequent calls to inherit these configurations. Now we're going to initialize our 2 graph databases. The first parameter defines the directory which we want to iterate over and collect all files for ingestion. And then the properties below control some of the other behaviors. One of the important callouts is how we specify the storage context. This is where the construct is going to automatically populate our remote database as the files are processed. The second index you see underneath is a separate database for our structured records. You'll notice that the documents property is defined as an empty list. This is because the data is ingested as we iterate the results from our relational database later in the script. Now, if we switch to our query script, we have our general imports. You'll see I'm using Streamlit for the UI demo from earlier. We have our Llama Index modules, which are the same as from our previous script. We have our Bedrock defines, our database connection information, and we have some properties for how we want our tuple retrieval process to behave on request. Scrolling down, there's our Boto3 client instantiation. Here we have the Llama Index settings again. But what's different this time is that instead of creating, I'm loading the index from existing instances. Then finally, we have the rest of the UI components that are bound to these indexes to query the results.